Hi everyone, here are the video solutions for the second part of the Chapter 8 test. So number 1 is an absolute value equation, and we know then that there will be two solutions. But before we can even begin to determine what those two solutions are going to be, we need to isolate this absolute value. So this needs to be completely by itself. You are not permitted to distribute into absolute value bars. You can distribute into parentheses, but you are absolutely not, so this is not allowed, but you are not allowed to distribute into absolute value bars. So you cannot do that. So the first thing we're going to do is divide both sides by 2, since the 2 is multiplied to the quantity in the absolute value bars. The 2's will cancel out, leaving us with the absolute value of 2x plus 5 equal to 3. And now that the absolute value bar is completely by itself, we can separate that into two equations to solve. The first one will be drop the absolute value bars, 2x plus 5 equals 3. And the second one will be 2x plus 5 equals the opposite of 3, which is negative 3. So minus 5 on both sides. So 2x equals negative 2, divide by 2, and x equals negative 1. So there's my first answer. Minus 5, so 2x equals negative 8, divide by 2, and x equals negative 4. Should always check your answers. So if I go back to my original problem and very quickly substitute those values. So if I put in a negative 1 and I multiply it by 2, that would be negative 2. Negative 2 plus 5 would be 3. And then the absolute value of 3 is 3. 2 times 3 is 6. So it does work. And you can just do this very quickly in your head if you don't have the time to work it out. So if I put a negative 4 in this spot, 2 times negative 4 would be negative 8. Negative 8 plus 5 would give me negative 3. In the absolute value bars, that would become positive 3, and 2 times 3 is 6, and that would also work. Number 2 is another absolute value question, but this time it is in the form of an inequality. So again, I know that there's going to be two answers. Not sure why I can't get this to slide down. There we go. All right, so, oh wait, sorry, no absolute values. I'm sorry, take that back. I was too worried about trying to slide my page down. No absolute values this time, which means that trying to get the absolute value bars by itself and setting up the two equations is not going to happen. These are just regular inequalities. This is the AND type, and I know that because only the AND type can be written as one compound inequality. The OR types, of course, have to be written as two separate ones. So I'm going to try to get this x by itself. There's actually 3 sections that I'm going to have to solve. So it's sort of like needing to make 2 lines. So whatever I do to one section, I have to do to all 3. So I'm trying to get this x by itself. So I'm simply going to add 4 because, well, that's the only way to isolate that x. And then I'm going to add 4 to the other sections as well. Negative 5 plus 4 is negative 1. Bring down the sign. 2 plus 4 is 6. Bring down the sign. Now, had I divided by a negative or multiplied by a negative, I would have had to reverse my signs, but that did not happen. So on my number line, I'm just going to make a real small one here. I'm just going to have 0 in the middle and go with my smallest number and my largest number. It's going to be everything from negative 1 to 6. Number 3, so this is an OR type problem, so all I have to do is solve each inequality separately and then connect it with the word OR. So minus 4 on both sides, negative 3h equals, 15, divide by negative 3, and that was a less than or equal to sign, but notice that I am dividing by a negative, so I am going to have to reverse my sign and make it a greater than or equal to, and then a negative 5. And of course it's an OR. So I'm going to add 3 to both sides. So negative 7h is greater than or equal to 21. Again, I am dividing by a negative, so I will have to reverse my sign. So here's my final answer, or not. I'm not really sure until I go ahead and I make my graph. I mean, it looks like it's the final answer, but there's always the possibility that it could change when I look at it in its graphed form. So let's put 0 here, -3, and -5. Always start with the smallest number, and they get larger as they go to the right, positive infinity, they get bigger. So let's see, h can be greater than or equal to -5, so that's going to be all of the numbers that head towards positive infinity. H is also any number less than or equal to -3, so those are going to be all the numbers that go towards negative infinity. Now, because it's or, that means it's the union. Remember the letter U that we used for union, meaning that it can be in one or the other. So all of these numbers would work in the compound inequality. All of these numbers would work. So it is going to be all of the numbers. So the answer is actually all real numbers. And if we were looking at it in notation using braces or brackets, it would look like this. I forgot to show this one over here. So that would be everything from -1 to 6. Okay, moving on. Number 4 and 5. Now we're getting into an absolute value inequality, whereas this one is not. So make sure you know the difference between, when am I going to have to break it up and make it into 2 and versus, something like this. Okay, so whenever we are dealing with absolute value, we always must get it by itself first. So I'm going to subtract the 4 that's here. So that's going to keep my absolute value of 2n minus 1 less than or equal to 7. And now I'm ready to break that up into my two inequalities. So I'm going to have 2n minus 1 because we dropped the absolute value bars, keep it exactly as is, and then I'm going to drop the absolute value bars, and I'm going to switch my sign and also make that an opposite number. So it'll be a -7. I also have to decide right here. This is, decide. This is when I have to decide whether it's going to be an and or an or type problem. So once the absolute value bar is completely by itself, this is where I'm going to decide if the absolute value is less than or equal to, then it's going to be an and type. So we don't really want to make that decision here, because what if I had to divide by a negative number? So we need to make this decision after the absolute value is by itself, but before we break it up. So I know this is an and type, so now I know that. So I'm going to add 1, add 1, add 1, add 1. So 2n is less than or equal to 8. 2n is greater than or equal to -6. Divide by 2, divide by 2, divide by 2, divide by 2. Kind of taking a shortcut here and solving them at the same time. So one answer is all the numbers less than 4. So that's how we would say that. All of the numbers. That's what that represents. So all of the numbers less than 4 and all of the numbers greater than or equal to -3. So let's draw our graph, see what that's going to look like. I don't really have room down there, so I'll do it here. Okay, so all of the numbers less than or equal to 4 and all of the numbers greater than or equal to -3. Let's make our number line. So all of the numbers less than or equal to 4 will go this way. All of the numbers greater than or equal to -3 will go this way. And the word and is the overlap. So and means overlap. So I'm going to look very carefully at my graph. Let's see, they're going to overlap from here to here. So all of this is my solution. So my answer is going to be this section right here. I'm going to get rid of those so as not to confuse myself. Here's my final answer. And that would also be everything from -3 to 4, including those two numbers. I could also say that my answer, it was an n. I could also say that my answer is everything between -3 and 4. So, either of these could be possible solutions if you were taking, let's say, a multiple choice test. Okay, number 5, this is just a regular compound inequality. It is the AND type because it's the only one that can be written as this one jointly compounded type. So I am going to try to get this x by itself. So I am first going to add 5 to everything. So that's going to give me 2 is less than 2x, less than or equal to 6, and then divide everything by this 2 right here. So my answer is 1 is less than x, which is less than or equal to 3. So there's my final answer, or it could be everything from 1 to 3, or it could look like this on a number line. I might as well put 2 in there while I'm at it. There we go. All right, moving on. Number 6. So number 6 is a regular compound inequality, so I'm just going to solve for x. So minus 2, negative 5x is less than or equal to negative 5. Divide by negative 5, and don't forget to switch that sign because I am dividing by a negative. So greater than or equal to positive 1. Or, let's see what happens here. I'm going to subtract 5 from both sides. I got so excited that I was switching my sign, I wrote it really big in this spot here. So now I'm kind of running out of room. So I don't have to switch my sign this time. This is an OR answer. So let's take a peek at what it's going to look like on a graph. So I have a negative 1 and a positive 1. X is everything greater. Oops, that is so wrong. Let me undo that. That was completely wrong. Okay, so x is everything greater than or equal to 1, or x is everything less than or equal to negative 1. So here is our answer. So if we were going to be writing this out, we always read it from the left to the right, just like we would a sentence. So it's going from negative infinity to the negative 1, and it includes the negative 1. OR type problems are union or just a regular U, and then it's going to pick up again at 1, and it's going to go until positive infinity. Number 7, compound inequality. I am allowed to distribute because these are parentheses, not absolute value bars. If they were absolute value bars, I would absolutely not be allowed to do that. I think I saw some of you in class dividing both sides by 3 first, and that is totally allowed. The only time I wouldn't recommend that is if they didn't divide evenly, but they do in this case, so it would have been okay to do. So x is less than or equal to 1/2, and that's going to be 2x minus 14 is less than negative 6. Add 14 to both sides. So 2x is less than 8, divide by 2. So x can also be less than 4. So this is something that doesn't happen all the time. In an AND type problem, I have both of my inequalities going in the same direction. So let's see what that's going to look like when I graph it. So 1, 2, 3, 4. Where's 1/2? 1/2 is here. So let's see. That first inequality is going to represent all of the numbers that are less than or equal to 1/2. And x is less than 4. So the word and actually tells us to choose the overlap of the two, which is this section right here. So my final answer is going to be that graph right here, which is everything from negative infinity to 1/2, including 1/2. So I would either say my final answer is this graph, or this if I'm using this type of notation, or I would just actually say, here's my answer. I wouldn't need to include that because it can only be in this section. So any of these 3 would be considered part of the answer. All right, hopefully you're doing great with this. Again, struggling with sliding this. What is going on? Okay. And number 8 and number 9 are both absolute values. So Remember what I said earlier about absolute value bars? Don't decide whether it's and or until we get the absolute value by itself. So I am first going to subtract 5 from both sides. So negative 3 times the absolute value of x minus 4 is greater than or equal to negative 9. This is attached by multiplication, but I am not allowed to distribute. No distributing, not inside absolute value bars. So I'm going to divide both sides by negative 3 to get rid of that. So the absolute value of x minus 4 is actually now going to switch to, so there's a little switching going on, to less than or equal to positive 3. And thank goodness that was a negative, because absolute values can't be less than or equal to a negative, so we don't have to worry about that, though. Absolute values can be less than or equal to 3. That's fine. So now I'm ready to decide if it's an and or an or type. So if the absolute value is less than or equal to, then it's an and type. So I'm going to break it down, drop the absolute value bars. There's my first inequality, and then I'm going to drop the absolute value bars, switch the sign, and make it opposite. So here's what I'm looking at, and I'm going to solve each one. I'm going to add 4. And again, I'm going to take a little shortcut here and just do them all at the same time. And x is also greater than or equal to 1. So let's take a peek at the graph to see what it's going to look like. So 0 up to 7. 1, 2, 3, 4, 5, 6, 7. Okay. So everything less than or equal to 7 goes this way. Everything greater than or equal to 1 is going to go this way. We're looking for the overlap. So that's this section right here. So my final answer is everything from 1 to 7. So get rid of that so we know what our final answer looks like. So this time the answer could be this. It could be the graph. It could actually be everything from 1 to 7, including 1 and 7. Or I could also say that x is everything between 1 and 7. And remember, we always write that in order from least to greatest using less than signs, or in this case, less than or equal to. So there's actually 4 different ways. Could look like this, could be the graph, could look like this, could be the inequality. There's 4 different ways to show that answer. Number 9, absolute value is already isolated. It's greater than negative 2. So you might be thinking, oh, wait, it can't be equal to negative 2. It can't be less than negative 2, but there are numbers that are greater than negative 2. So we do need to proceed with this. This is going to be an or type. Drop the absolute value bars. It is greater than or equal to 2, or 4x plus 5 is less than the opposite of 2, negative 2, which is a positive 2. So I'm going to go ahead and subtract 5, subtract 5, subtract 5. So 4x is greater than negative 7, or 4x is less than negative 3. Divide by 4. And it looks like x is going to be greater than negative 1 3/4, or x is also anything less than negative 3/4, and it's the union because we are trying to find one or the other, so the union of the two. So let's see, what should my number line look like? Let's go with negative 2, negative 1, and 0. And negative 1 3/4 would be about right here. So everything greater than negative 1 3/4 would go this way. And negative 3/4, let's go about here. So that would be everything this way. And if it's the union, which means it can be in either one, then it's all real numbers. It's every number. So our final graph would just be the whole number line. Or we could say negative infinity to positive infinity. Okay, number 10. This is just a compound inequality. So let's see, I'm just going to solve them each. So here's my 2. I'm just going to solve them. Minus 20 minus 20. So 12 is less than or equal to 3x. Divide both sides by 3. So 4 is less than or equal to x. I always like to switch it and put my x on this side, so I always read it backwards. So you do actually have to switch your sign when you read it backwards. So there's one answer. Or minus 1, so 16 is less than negative 8x. Divide both sides by negative 8. So that is going to change my sign, and then I'm actually going to switch my sign again because I want to bring the x over, which actually takes me back to what it looked like in the beginning, but for two different reasons. Okay, so here's my number line. Let's put a negative 2, a 0, and a 4 on here. So x can be everything greater than 4, or x is everything greater than negative 2. So I'm looking for one or the other, not the overlap this time, one or the other. So actually, the answer is going to be everything right here from negative 2 on to positive infinity. So the final answer would actually just be this inequality, this graph, or I could say everything from negative 2 to infinity. And let's see how many more we have. Number 11, so all you have to do is write the compound inequality. A number is more than negative 10 and at the most negative 1. So a number is more than negative 10 and at the most, which means less than or equal to negative 1. But we could also rewrite our and compounds by putting the smallest number on the left, less than x, which is less than or equal to negative 1. So either of those are the answer to question 11. Number 12, arrows that go out are always going to be or. It's the union of this graph with this graph. So I'm just going to say x is everything less than 3 or x is everything greater than 5. And that's the only way I can write that one. I can't combine them into two. So that's the answer to number 12. Number 13 is also or, because the arrows are going out. So x is everything less than or equal to 1, or x is everything greater than or equal to 4. Those are our answers. So if it had been the opposite, had it been like this little section here, if it looked like that, then I would say that my answer is 1, which is less than x, which is less than 4. That would represent that graph. That's only an if question, okay? That was just me showing you a little extra.